Today, Monday, September 9th, we're talking about two variable systems of equations. So last week, we talked about systems of inequalities. Okay, so there was two variable and there were two inequalities. We did some that were three inequalities, but we looked at solving those by graphing and looking for like the overlapping shaded region. That's where our solution was found. What we're going to look at today, now instead of inequalities, we're looking at equations. Okay, so that's the difference. Equations means there's an equal sign. Okay, so not a greater than or less than, but an equal sign. So there would, if we were to graph these, there would be no shading. They would just be lines. So on the inequalities, the solution was in the overlapping of the shaded regions. Okay, for these though, our solution, to be a solution, you can come grab the paper back here. To be a solution, you have to make both equations true. So to do that, that means that the point would have to fall on both lines. So if we have two lines and we need a point, bless you, that is on both lines, where would that be? Can you visualize it? If I have two lines, let's say I have this line and I have this line. What is the only place that is on both the blue and red line? Where it intersects. That point right there where it intersects, that's the only point that would be a solution to both of those. Okay, so when we talk about a solution or solving systems of equations, there's only going to be one solution, okay, because there's only one point that would make both of these, that would fall on both of these lines, or if we had them as equations, it would make both of the equations true. Okay, so that's what's a little different than what we did last week with the inequalities. The inequalities had a whole section of shaded region that what you could find solutions in. Okay, now there's only going to be one solution. Okay, so the point where the lines intersect is the solution system of equations. Okay, so we're going to write that like that. Our answers are going to be written as an ordered pair. We're going to have to find an X and a Y value and give that answer as an ordered pair. So far, so good? Does that make sense? Now, to do that, the process, the steps for solving. Okay, the first, you're going to have, so you're given two equations. The first thing that you're going to want to do is solve one of the equations for X or Y. It does not matter. You get to pick X or Y, whichever one is easier to solve for in one of the particular equations. So looking down here at these examples, number one, the first equation is already solved for Y. Do you see that? So step one is already done. One of the equations is solved for X or Y. Okay, so step one is done there. Okay, then step two is to substitute this expression into the other equation and solve for the variable. Okay, so in this example down here, example one, step one, oops, that's supposed to be a highlighter, not a line. Step one is done. It's in Y equals. Step two, we are going to replace Y in the other equation with the expression that it's equal to. It's equal to 6x. So we're going to make that substitution. I'm going to come here and I'm going to say instead of Y, I'm replacing it with 6x. Okay, so I made that substitution. So I'm going to substitute the first time. Now, part of this step is to solve for the variable that's left. What's the only variable left here? X. Okay, so I'm going to solve for X. So I've got to simplify first. So the 3 times 6x is 18x. Combine like terms, I've got 20x. And how do I get rid of that 20 in front of the x? I'm going to divide it out. Get rid of that coefficient. And I get x is -1. Okay, this is not my answer. I am not done. Do not just box this in and be like, done. Okay, that was only step 2. Step 3 now that we have one of our variables, we are going to substitute again. We're going to substitute that answer into the revised equation from step 1. Okay, when we got the first equation and solved for one variable, now we're going to go plug that back into there. Okay, so we're going to substitute again. Now, in this case, it's not a revised equation. It is the original equation, y equals 6x. So that's what I'm going to substitute into. Instead of x, I've got -1. So I'm substituting -1 in for x. And now I solve that. And I get -6. Now up here, let me fill in this blank. Okay, so we did the substitution and solved again. So substitute, solve, substitute, solve. Okay, little cycle there. Now that I have both x and y, how did I say I'm going to write my solution? Do I just box in x equals and y equals? Yeah, like a coordinate, okay, an ordered pair. So my solution is -1, -6. That is a point. If I were to graph both of those lines, that is the point where they would intersect. Okay, so let me show that to you graphically. Okay, Desmos is a fantastic tool. It's very helpful, but I don't want you just relying on Desmos, but I do want to show you this side by side here. Bless you. See, I've typed in my original 2 equations that I was given, and here's the graph of those 2 lines. That point where they intersect, is that what we got? -1, -6? Yeah. So you can confirm this graphically with Desmos. So I'm fine with you checking your work as you work, but please don't just do it in Desmos, because there are going to be times where you have to be able to do this algebra. Okay, maybe we're going to have a quiz and you don't get to have Desmos, because I want to see, do you actually know the steps? Okay, so use Desmos to check your work. Do not use it to do the work for you. Does everybody understand that? Okay, so you can check your work with Desmos all you'd like, but don't just do it in there. All right, let's try another one. Let's go through that process again. I'm going to go a little bit faster this time. Now, again, one of the equations is already solved for one of the variables. So step 1 is done for me. So I'm ready to substitute that in the other equation. So when I go to substitute this, here's my substitution. That's what I replaced y with, because y is x plus 9, so I can substitute it. Now I need to simplify on the left. Now on this simplification, because this is an expression, not just a monomial, I do have to distribute that +8. So I'm going to have 3x plus 8x plus 72 equals -5. I've got some like terms I can combine here on the left to 11x plus 72. And now I'm ready to start moving things across the equation because I've simplified as much as I can there on the left. So I will subtract the 72 because that's the opposite operation to move the constant. which leaves me with 11x equals negative 77. Now to get rid of the coefficient, I will divide. The opposite of times 11 is divided by 11, which simplifies to x equals negative 7. That is not my answer. Okay, what do I do with that now? Now I'm going to take that x value, negative 7, and I'm going to plug it back into that first equation of y equals x plus 9. I'm going to plug it in here for x. So this is going to be y equals negative 7 plus 9. Because that was my substitution. Okay, so that is what? What is y? Y is positive 2. So my solution is negative 7, positive 2. All right, if we flip this over, I'm going to give y'all a minute to try number 3 on your own. I want you to give it a shot. This one is very similar, but instead of y equals being given to you, the first equation is given to you as x equals, but it's still solved for a variable. It doesn't matter if it's x or y. You're solved for one of your variables, so you can plug that in for the x in the second equation. So you'll just be solving for y first and then for x instead of vice versa. Okay, so I'm going to give y'all a minute to try that while I put in attendance. If you're watching this as a video, just pause the video and give it a shot and then come back to chat. Guys, everybody should be trying this one.
Hello.
Guys. Does everybody think they've got it, or you need another minute? All right, what did y'all get for your, so you end up solving for y first. So what did you get for your y? Negative 1 is correct. So let me unfreeze my screen here. Okay, so here's the work. When you solved for y, you should have gotten negative 1. And then when we come back and plug that negative 1 into that original x equals equation, what do you get for x? So positive 3. So your solution here should have come out. Oh, I almost wrote it backward. Make sure you write x and then y, ordered pairs, x first. So it's 3, negative 1. If you accidentally wrote negative 1, 3, just switch that. Okay, and don't make that mistake again. I almost made it too. All right. What's different about this last one is that neither equation is given in x equals or y equals. So this one, we actually do have to do step 1, which is solve one of the equations for X or Y. You get to pick. So I like to look at both equations and ask myself which one's going to be the easiest to solve for one of the variables. So what do y'all think? That first equation, Y, has no coefficient. It's an understood 1. So that's going to be the simplest, meaning the fewest steps to solve for. Okay, so I'm going to use the first equation, and I'm going to come over here, and I'm going to solve that one for Y. Because the only thing I have to do to solve that for Y is move 2x over by subtraction. Now remember, you cannot combine this -2 and -2x because one's an x term and one's a constant. So be sure you keep those separate. Okay, so that's just a little bit of extra work for step 1. Now I'm going to take that and substitute that in for Y here. So that's going to be 5x plus 3. And then instead of Y, I'm plugging in -2x minus 2 equals -8. So I substituted that in there, and now I'm ready to simplify. So this 3 has to be distributed. So I end up with 5x minus 6x minus 6. Bless you. Over here, when I combine like terms, I get -x minus 6 equals -8. Move the constant by opposite operation. And then divide out the negative. Some of you don't need to show the dividing out the negative. You understand that just all the signs are going to change. And so we end up with x is +2. So now that we have that, that's what we're going to use for our last step, which we're going to take that and we're going to plug it back in, not to the original equation. Technically, you can use either of the original equation, or not either, because, well, yeah, either. So you could use either of the original equations and take that 2 and plug it in for x and solve for y. But it's going to be easiest to use this revised equation where it's already solved for y. So I'm going to come back to that y equals -2x minus 2. And that's where I'm going to plug in my x. Okay, and my x is +2. That is a lot of 2's. Okay, but I'm plugging that in there. So I end up with y is -6. So what is my actual answer? How do I write my solution? Yes, as an ordered pair, x, y, to -6. You'll feel all right about that? So this process, again, is called substitution. There are multiple ways to solve systems of equations. Today's was focusing on substitution. Okay, we will talk about other methods. There's graphing, which does most graphs it for you, but if you know how to graph an equation by hand, like we were doing with the inequalities, you can solve by graphing. You can solve by elimination. But today, just focused on substitution. Do y'all feel good with the substitution process? Okay, so you have a Delta Math assigned to you in Delta Math. So I'm going to pull up your sample student page here, what it should look like. So when you go in, you should have 2 upcoming assignments. One is from Friday. It means that the due date is upcoming. The assignment from Friday is due tomorrow by 11:59 p.m. Okay, so if you have not completed that, if it's still showing up here instead of the completed folder, then you can finish it first. I would recommend finishing that one first because it's due first. Okay, but if you're ready to start today's practice, today's is short and sweet. There's only 3 types of questions. They're all substitutions. You can see level 1, 2, 3. So that just gets a little progressively more difficult. So level 1's the easiest, level 3's the most complex. And I'm just asking you to do 2 of each. Okay, so 6 questions that you need to get right for today's practice. All good? Y'all can talk to each other, use those notes. I'm happy to have you check your work in Desmos, but be doing the algebra on scratch paper to practice that process. If you need scratch paper, there's some available back here in the back of the room. You're welcome to grab some of that.